So today I'm going to explain you vectorless RAG. So RAG has evolved now, and there is new thing. We don't need to create vector embeddings. No need to save into the vector database. No need to create a chunking. So this new thing vectorless RAG because of the LLMs has increased its context window. So and in the future maybe this also vectorless RAG also we don't need this vectorless RAG as well. So we have all LLMs that have a very huge vector embedding. So these things also are not needed. So let's discuss this evolved RAG today. What are the things change inside in the RAG pipeline now. So this vectorless RAG called as page index, the RAG system that thinks instead of searches. So in traditional RAG, what happens that on the basis of similarity search, we get response top k chunks and on the basis of the most relevant answer, we get as a response. Now this vectorless RAG works with the reasoning. Work means it create a graph like structure, and on the basis of for better understanding, you think like a decision tree where like top node its branches is there. So this kind of structure is happening with this page index. Like in previous RAG, we when we have document or PDF something, we we split into chunks, generate embeddings, we save that into the vector DB, and after that, on the basis of cosine similarity, we get answer. So retrieve by similarity misses the relevant intent inside the similarity. Retrieves by similarity misses narrative intent. Also, chunking breaks the document structure. Why matching instead of logical navigation? These are the few things happens with the traditional RAGs. To solve this problem, this page index means vectorless RAGs comes into picture, where we have a document, we create a build a table of we TOC kind of tree we build there, and after that LLM reasons over structure and navigate to the section and gives us a precise answer and situations on the situations. So these are the I would say this is a very big thing in the RAG pipeline, where inside in while working with the traditional RAG, we create embeddings, and we know that while creating embeddings, while there is a fixed site chunking, overlap chunking, we there is a chances of the RAG don't have the appropriate answer for the question. Like most of the times while implementing these things, I face that issue. So inside this vectorless RAG or page index, this problem has get solved. So now how page index works. So for inside the phase one, we build a tree like a structure, and after building a tree like a structure, like structural detection, hierarchical mapping, and node summarization. Each node gets a semantic summary for the specific information that and that helps to retrieve the signal. Inside the phase two query, when the user asks the query, then you after ask the query, the first thing happens as structural search. LLMs read the TOC tree and summarizes the not in full document, just summarize not full document, just summarizes, and after that it dive into the document and retrieve only 2 3 relevant node sections. Suppose there is some information, like talking about myself, there is some information present on page 2 or 3, and some information present at 100th of page. And in that case, by creating nodes, that 100th of information also created some node somewhere with my information. So by using that, we solve that problem as well. So yeah, as I said, inside the traditional RAG, we focus on semantic search. Also, we use cosine similarity, and inside this vectorless or page index, We are moving with relevance. What is the actual relevance of the user has asked the query. So structure reasoning is there. They are like two cognitive tasks separated. Native determine where the answer should exist, structure first, and extract. Read only that session and generate a precise cited answers. Like a human, it works like a human. You don't skim every page. You go to the chapter where the answer lives. That totally like a human kind of behavior it works. So when page index shines, what are the use cases where page index works very better uh, very better while comparing with the traditional RAG? Financial reports, legal contracts, policy documents, academic papers, regulatory feelings, long narratives. Yes, why like while working with this type of problem statement, page index shines very better in better way. So we can say stop searching, start reasoning. So this is the best thing while implementing or using this page index, where it focuses on reasoning instead of searching the top k chunks or something.